The next type of reaction that occurs in aqueous solutions is called oxidation-reduction reactions. And in oxidation-reduction reactions, we are interested in the transfer of electrons from one species to another. Now, keep in mind that in acid-base reactions, we were talking about proton transfers. In oxidation reduction or redox, so a lot of times we shorthand oxidation reduction by saying redox. In oxidation reduction reactions, we're dealing with the transfer of electrons. So let's take a look at an example reaction. To make a molecule of MgO, you have to combine a magnesium ion and an oxide ion. But if you look at the reactants, magnesium and oxygen in their elemental state, there is no charge. So here's the reaction that we've got. We've got magnesium plus oxygen gas, and this yields 2 MgO, which is solid. Okay, so this is the reaction that we're dealing with. Now, what we can do to help us see the transfer of electrons, because we're saying that this has 0, this has a charge of 0, O2 gas has a charge of 0, but Mg2 plus, Mg has a charge of 2 plus, O has a charge of 2 minus. Okay? To help us see this a little bit better, we can actually break this down and write half reactions. So a half reaction, what that does is that it shows us the electrons involved in a redox reaction. Okay, so we can actually write a half reaction based on just what magnesium is doing, and then we can write another half reaction based on oxygen. All right, so let's take a look at this. So one reaction, if we were to write just magnesium, we see magnesium, we have 2 moles of magnesium, okay, and it's solid. And that's on the left-hand side. On the right-hand side, we see that we have 2 moles of Mg2+. Now, in order for this to go from a charge of 0 to a charge of 2+, it had to lose 2 electrons. Okay? Now, that's 2 electrons for just 1 mole of magnesium, but you got 2. So you got to multiply this by 2, so that's 2 times 2, which is 4. So on the right-hand side, we say plus 4 electrons because each magnesium is giving up 2 electrons. You got 2 moles, so you've got 4 moles of electrons to deal with. Okay? We can also write a half reaction for the oxygen. On the left-hand side, we have O2, which has a charge of 0. And then on the right-hand side, you've got 2 oxide ions, which has a charge of 2 minus. So in order for the left-hand side to go from 0 to 2 minus, it had to gain electrons. So for that to happen, this had to pick up 4 electrons because, again, we're dealing with 2 oxide ions. 2 times -2 would give you -4. The only way you're going to get that is from 4 electrons. So you have one species that's giving up electrons, and then you have another species that's taking it in. So any species that gives up electrons, we say that that species is being oxidized. Okay, so we say that, actually I just spelled it the British way, sorry. So let me change that. That's a Z. All right. So if a species is losing electrons, we say that's oxidized. And if a species is gaining electrons, then we say that's reduced. So the oxygen is gaining the electrons, going from the left to right is gaining electrons, so the oxygen is being reduced. Magnesium is losing the electrons, so that's being oxidized. Now, what's really nice is that if you take these two half reactions and add them together, you should end up with almost the whole reaction. So that's pretty cool. All right, now there's a couple different ways of us to remember, mnemonic devices of remembering what redox means. So the way I remember it is Leo the lion says "gur," where you're losing electrons, that's oxidation. If you're gaining electrons, it's reduction. Okay. Another way of doing it is, or saying it, is oil rig, where oxidation is losing, reduction is gaining. Either way you want to go with it, hey, go with it. That's cool. Now, every time we look at an oxidation-reduction reaction, we ask ourselves 4 questions. Who is being oxidized, meaning who's losing electrons? Who is being reduced? So that means who's gaining electrons. Okay. Who is the oxidizing agent? And who is the reducing agent? The oxidizing agent, what this means is that this species accepts electrons and causes a species to become oxidized. And then if you're the reducing agent, you donate electrons and cause a species to be reduced. All right, so let's try to answer these 4 questions based on the reaction that we've seen. So based on this previous example, we know because we have the magnesium losing, the 2 moles of magnesium losing 4 moles of electrons, we know magnesium is oxidized. And because O2 picks up the 4 moles of electrons, O2 is reduced. All right. So those 2 are the easiest to answer right off the bat. Now, the next 2 are the more difficult ones. So if we're trying to answer the oxidizing agent accepts the electrons. Okay, so who accepts the electrons? In this case, it's the O2. The O2 picks up the electrons, but here's the thing, it also causes a species to lose the electrons. So if O2 is gaining the electrons, where does O2 get those electrons from? They get it from the magnesium. So O2, because O2 accepts the 4 electrons, 4 moles of electrons, okay, because O2 accepts the 4 electrons from 2 moles of magnesium, O2 is the oxidizing agent. All right, so if O2 is your oxidizing agent, then that means that magnesium is donating the electrons to oxygen, but it's causing oxygen to take in those electrons. So because magnesium donates the electrons, magnesium is the reducing agent. Okay, now what's really nice about these reactions right now is that if you are being oxidized, you're going to be the reducing agent. And if you're being reduced, you're the oxidizing agent. So that's really nice right now. In Gen Chem 2, if you're being reduced, you may not necessarily be the oxidizing agent. And if you're being oxidized, you may not necessarily be the reducing agent. There may be more species involved than what meets the eye. So keep that in mind. So right now we're just keeping everything neat and tidy. If you're oxidized, you're the reducing agent. If you're being reduced, you're the oxidizing agent as well. Okay. Now, the other thing to keep in mind is that the number of electrons involved in an oxidation reaction have to be taken in. So if you generate 4 electrons, then you got to find that species got to take in 4 electrons. So keep that in mind. The electrons have to balance out. Okay. So let's try another reaction. Let's try this. What if you had solid zinc and copper 2 sulfate? Okay. And these react to form zinc 2 sulfate plus copper. All right. So what we're going to do is write a half reaction for zinc and write a half reaction for copper. Now, what about the sulfate ion? Because sulfate shows up here. Now, sulfate, its charge, its oxidation number never changes. So in this case, on the left-hand side, zinc is 0 because it's by itself, it's elemental. Copper is 2 plus, sulfate is 2 minus. But on the right-hand side, sulfate is also 2 minus, so that never changes. Sulfate is your spectator ion. In this case, zinc becomes 2 plus, copper is 0 on the right-hand side. So if we write a reaction based on what we see, actually, this answer for number 1 is this. If we drop out the spectator ion, you're going to get a reaction that says this. You have zinc plus copper 2 plus yields zinc 2 plus copper. And so if we write a half reaction based on what we're seeing, one reaction is on zinc. Actually, I just wrote that too big. Let's try this. Zinc is going from 0 to zinc 2 plus. So that means if it's going from 0 to 2 plus, it has to be losing 2 electrons. And if copper is going from 2 plus to copper 0, that means copper's got to be gaining 2 electrons. And so those are our 2 half reactions. So based on what we're seeing, because zinc loses the 2 electrons and forms zinc 2 plus, zinc is being oxidized. So as zinc is oxidized, that means by default, it's got to be your reducing agent. And if copper 2 plus is being reduced, so it's gaining electrons, that means it's your oxidizing agent. Pretty cool. So every time we take a look at a reaction, those are the things that we're trying to figure out. What species is being oxidized? What species is being reduced? What species is your oxidizing agent? What species is your reducing agent?